Hello students, my name is Bernhard Flaxon Masebo, a senior mathematics teacher holding bachelor degree of education majoring in mathematics. I'm an expert in this subject. I have been sharing with you the topic of advanced mathematics, particularly our beloved topic. This is algebra. And we have been going through some important parts, just starting from exponent, logarithms, series, partial fractions, the principle of mathematical induction, and then we went for the part of polynomial functions. So today, I'm introducing you a very nice part. This one is concerning about the relationship between the roots of the polynomial function. Let's go. We say the relationship between the roots of a polynomial function. We will be checking two parts of polynomial functions particularly. So here we say case number one, let's check for quadratic equation. We say clearly when given ax squared plus bx plus c equals to function f of x. So we say setting f of x equals to 0, we have ax squared plus bx plus c equals to 0. And then dividing by a throughout, this is, it could be giving x squared plus b over ax, c over a equals to 0. Upon solving these quadratic equations, we say, upon solving this, we say, upon solving, gives x equals to alpha and x equals to beta. This is a quadratic functions with degree 2. So upon solving gives two zeros. And mind you, these zeros, we said these are simply roots of the quadratic. So therefore, before getting the zeros, treating alpha, take it to the other side. This one gives us x minus the alpha. So if you multiply x minus beta, which are the factors from the quadratic, will be proportionally giving x squared plus b over a, x plus c over a. So expanding this part, expanding the other side, this side. So we say when expanding that, we will be getting x squared minus alpha plus beta, x, alpha times beta, this one proportional, equivalent to x squared, b over a, x, c over a. This is just after expanding this. So if you comparing corresponding coefficients, so you can see coefficients here is 1, as well as here is 1. But taking this coefficient of x is going with coefficient of x, we say we will be having alpha plus beta is giving negative b over a upon taking negative to the other side after being compared. And then we will be having alpha times beta, this is giving c over a. So we say these are the sum of roots of the quadratic functions. Sum of roots for the quadratic equation is negative b over a, while the product of the roots also is just c over a. So a mathematician will not be wasting time solving quadratic equations, getting the roots, and then at the end finding the sum of these two roots and the product. That could be wastage of time, and the solution could be too mechanical, too rigid. Therefore, you will be a good mathematician, saving time and space, just using this trick to find the sum of root and the product. So we say work with these important roots. So let's check again with case number 2. Case number 2, we are now in the part of cubic function. After checking the quadratic, we say cubic function. Let's check with the cubic function. With the cubic function, there is nothing new. Here we simply say, given f of x equals to ax cubed, bx squared, cx plus d. So say when we're setting this part 0, therefore setting this part 0 and dividing by a, we will be getting this thing here, x cubed plus b over a, x squared, c over a, x and d over a. Now this is proportionally equals to 0. So we say upon solving this, it could be giving 2 roots. So we say gives x equals to alpha, x equals to beta, and x equals to gamma. So there exist 3 distinct roots from the polynomial functions. However, we say the roots can be 3 or less than 3. But particularly here we are considering when the polynomial gives 3 distinct roots. So with this one, it is enough to say we will be just saying x minus alpha expanding with x minus beta and x minus gamma. This one is proportionally equivalent to x cubed plus b over a x squared plus c over a x plus d over a. So we are now able to make the expansion on this part, performing appropriately expansion on this. So we say upon expanding carefully, you could be taking x times x. So this first part here, we expand the first to x times x times beta. This one is giving x squared minus x plus alpha plus beta, x plus alpha beta. This one also needs to be expanded with x minus beta, minus gamma I mean. So with this is proportional to x cubed plus b over a x squared, c over a x plus d over a. So expanding again carefully, taking x and this part. This is one is giving x cubed minus alpha plus beta plus gamma x squared. This is going to give a plus alpha beta, beta gamma, alpha gamma. And this one goes with x minus alpha beta gamma. This one is equivalent to this part, which is x cubed plus b over a x squared, c over a x plus d over a. So comparing corresponding terms here. Comparing corresponding terms, this is the same we say comparing corresponding terms. When we compare corresponding terms here, it is nothing. We will be just taking the coefficient of x squared. This one goes with this. We will be having b, this we say, we will be having alpha plus beta plus gamma. This one is giving negative b over a. So in taking, we call symmetrical arrangements. Alpha beta, sum of pair we call beta gamma and the alpha gamma. This one is giving c over a. Mistaking this goes with the coefficient of x. And the product alpha beta gamma. This one takes negative d over a. So these are also important formulas which are so useful when you're trying to write our expression in that form. Now let's check. We have seen the trend when it is power 3. What would happen if the polynomial could be like x power 4, b over a x power 3, c over a x power 2, d over a x, e over a equals to 0. So in this case, considering that the roots is alpha, beta, gamma, and lambda, let's say, we could be writing the same trend, that the concept could be x power 4 minus sum of root alpha plus beta plus gamma plus lambda x power 3. In the same way, we could be arranging here, we say this is going to become plus. This is the sum of pair. So sum of pair takes 2. So alpha beta plus alpha gamma plus alpha lambda plus, this time beta comes first, beta gamma plus beta lambda. So beta is done, plus again gamma lambda, this one x square. And the next one could be minus. Subtracting on this, it could be taking 3 roots. So taking 3, it means it's taking alpha, beta, gamma. So it could be alpha, beta, gamma, alpha, beta, lambda, alpha, beta, lambda. And then we take beta and gamma plus beta, gamma, lambda. And then finally finishing with the gamma, lambda, alpha. So we say gamma, lambda, alpha. This one, it could be taking x. And finally is plus alpha, beta, gamma, lambda equals to 0. So this one could be also giving the trick of the formula. So we can see these ones are so useful. We are now going to check how can we apply the trick of these sums of the roots to treat our questions. Let's go. So student, with the formulas we have seen about the relationship between the roots of the polynomial function, that is for quadratic function and for the cubic functions. And we have seen how one could use symmetrical arrangement, we call a cyclic arrangement, when you have more than 3 roots. Now let me introduce you to some important identity, and that is from the part of binomial, where from this identity, in combination with the formulas of the roots of the polynomial, we will be now checking for the worked examples and some challenging questions involving this part. Let's go. So we say relationship. We say some important identities. Some important identities. One, we say, when you take a plus b power 3, a plus b power 3, when you take a plus b power 3, this is the same as a cube, 3a square b, 3ab square plus b cube. And when you take a minus b power cube, so this is a cube minus 3a square b plus 3ab square minus b cube. And when you take a cube plus b cube equals 2, when you're taking a cube plus b cube, this one is going to give a plus b, open brackets, a square minus ab plus b square. So this is with when you take a plus b cube. So 4, when you take a cube minus b cube, this one also is giving a minus b, and here a square plus ab plus b square. In the same way, we have one other identity here. This one is evolving when we are having the power of 3. Let's check when we have the power of 3. We say with a cube, b cube, plus c cube minus 3abc equals 2. This one is giving us a plus b plus c, open bracket, see? So this one, our bracket in this part, let's call this is d. But this d Our D here simply means our D is taking our D, which is a product. This is A square plus B square plus C square minus AB minus BC minus AC. So this one is the one which appears in this bracketing. That is from, when you expand this, these are important identity. Let us check the other one. This one is involving, when you have A, this is for square, A plus B plus C square, this one is the same as to say A square plus B square plus C square, and here we say plus 2, open brackets. So say AB, BC, CA. These are important identities, which upon working with this, and with the sum, with the formula for sum of roots, product of roots to both quadratic and cubic functions, we're going to be checking some questions. Let's check worked examples. The roots of the quadratic equation 2x squared 5x plus 3 equals to 0 are alpha and beta. So it says find the equation whose roots are. So one can give A, whose roots are 1 over alpha and 1 over beta. So B, find the equation whose roots are alpha over beta and beta over alpha. So let's check on this. One of a very nice example, which says the roots of the quadratic equation 2x squared plus 5x plus 3 equals to 0 are alpha and beta. Find the equation whose roots are 1 over alpha and 1 over beta. So from there, we say we know that a quadratic equation will have x squared minus z, alpha plus beta, x plus alpha beta equals to 0. In other words, we say sum of root, product of roots. So with the quadratic we are given here, we must divide by these two both sides. So we say, in the other way, we say from our quadratic, what is alpha plus beta? Alpha plus beta from this is negative b over a, where our b is negative, so becomes 5 over 2. What is the product of roots? Using from this, which is c over a, therefore becoming 3 over 2. Now these are the roots of this quadratic. A quadratic equation which we need to find the root must be in this form. So we say, clearly, we know that always any quadratic equations is always in this form. We always say x squared minus z, sum, we simply say sum of roots times x and product of roots and then equals to 0. So the equation you want to find, it must be in this form, which is taking this form here. Therefore, we must say x squared minus sum of root. Our roots now we are told is supposed to be 1 over alpha and 1 over beta. X, which is our roots for the desired equation. And here product of roots, 1 over alpha times 1 over beta. This is 0. Therefore, you must be performing here mathematical operation on this part. The LCM here is the alpha beta. And here is going to become beta plus alpha. X plus, here is 1 over alpha beta equals to 0. Now in alpha plus beta, this is where we want to put the result for alpha plus beta taken from this equation, which is negative 5 over 2. And in alpha times beta, there is when putting the result for the product of the roots. So this one becoming x squared minus. So with beta plus alpha, which is the same as alpha plus beta, this is negative 5 over 2. And here, 3 over 2. This is x. Plus 1 alpha beta, this is the 3 over 2. So putting this reciprocal rule, 2 cancels. So you are getting x minus z plus 5 over 3 x, and here 2 over 3. So avoiding this denominator, you will be multiplying by 3, which one is giving 3x squared plus 5x plus 2 equals to 0. So the quadratic equation, which roots is 1 over alpha and 1 over beta, this is going to be appearing 3x squared plus this. So let's check with b. With b, b says find the equation whose roots are that. So using the same formula there, we will say x squared minus sum of root. Our root is alpha over beta plus beta over alpha x and the product. So alpha beta, we multiply with beta alpha. This is giving what? 0. So upon working on this one is x squared minus, so the LCM here, alpha beta. So dividing this is alpha square plus beta square, but x. Multiplication here, cancellation, so giving 1. So with this, you must be finding the result of alpha square plus beta square. Alpha square plus beta square, this is from this, which is the alpha square plus 2 alpha beta plus beta square. So instead of alpha square and beta square, which is this? So we will be just writing alpha plus beta bracketing square minus 2 alpha beta. So it means here becoming x square minus in this bracket. So alpha plus beta here minus 2 alpha beta, and with the denominator alpha beta with this x plus 1 equals to 0. So performing replacements, this is the one giving, so alpha plus beta, this is a result, negative 5 over 2, but square 25 over 4 minus 2, what is the alpha beta? 3 over 2 over alpha beta 3 over 2. We have x here plus 1 equals 2. This is simple to simplify. Cancellation this giving 3, and then performing this, which is easy to give. So this is our result. So you can see how it is interesting. We are going to check another example so as to broaden our understanding. Welcome. Let's go. So let's check example number 2. This one says the roots. It says the roots of the quadratic equation ax squared plus bx plus c equals to 0 are such alpha and beta such that one root is 5 times the other. Then says find the relationship between A, B, and C. You can see this question. This is an interesting one. It says the roots of the quadratic equation ax squared plus bx plus c equals to 0 are alpha and beta such that one root is 5 times the other. Find the relationship between ABC and ABC. You will see a very, very related equation of the same nature for the advanced mathematics by Tranta. So we say solution with this. We say clearly, we know if you take alpha plus beta, negative b over a. You take alpha times beta, this is c over a. But we say let beta equals to 5 times the alpha. Because we are told one root is 5 times the other. It means let us assume it is beta which is obtained by taking 5 times the alpha. One root is 5 times the other. So therefore, we will be having, we say, so from here now it's going to be alpha plus 5 alpha negative b over a. This gives 6 alpha, negative b over a. Color this is equation 1. Also, with alpha times beta, so beta is 5 alpha, so this is c over a. It follows 5 alpha square equals to c over a. So we have this trend equation. This is equation number 2. So we say, transposing equation 1 for alpha, we say alpha will be becoming negative b over 6a. So put this result of alpha in the second equation in this alpha. So becoming 5 alpha square. So in the press value of alpha, negative b over 6a. This one is c over a. So expanding this one, this is 5b square, 36a square, c over a. So this is a relationship. You can be crossing multiply, reducing for a. We could be having 5b square over 36a equals to c. So this is a relationship. You can cross multiply to express it. You can see how it is interesting. The question is so tactical. Now let's check another example. So let's check example number 3. Example number 3 says if alpha, beta, and gamma are the roots of 3x cubed minus plus 6x squared minus 4x plus 7 equals to 0. Then it says find the equation. Find the equation. Whose roots are? So A, find the equation whose roots are alpha plus 2, beta plus 2, gamma plus 2. B, find the equation whose roots are 1 over alpha, 1 over beta, 1 over gamma. C, find the equation whose roots, let's put C here. Find the equation whose roots are alpha plus beta, beta plus gamma, alpha plus gamma. So this is one of a very, very challenging question. A student needs to be intelligent enough to treat this question. Let us start working. This one is simply solved when you remember this, the cube for the roots. So we say solution for this one. Solution, starting with A. With A, we must find the sum first. Alpha plus beta plus gamma, sum of roots, negative b over a. So from our question here, this is becoming negative 6 over 3. This is negative 2. Again, taking the sum of pair, alpha beta, beta alpha, beta gamma, alpha gamma. This is c over a. So from this, negative 4 over 3. In the same way, finding the cube, alpha beta cube, negative d over a. So this one becomes c, negative 7 over 3. So with this information, we want to find the equation whose roots are these ones. But now we say, we know it is always x cube minus sum of roots, x square plus sum of pair, x, and then minus the product of roots. Product equals to 0. Now with this, so what is sum now? We will be finding sum, which is alpha plus 2, alpha plus beta, plus 3, plus 2. This is supposed to be, let's cancel this. Alpha plus 2, beta plus 2, gamma plus 2. This one is giving alpha plus beta plus gamma plus 6. But this result is known from here, which is negative 2. So putting negative 2 plus 6, this one is what? 4. So this one is going to be plugged here, repressed in this part. So sum of pair. Sum of pair, it means taking alpha plus beta, plus 2 I mean, and then beta plus 2. This is the first pair. Second pair, beta plus 2, gamma plus 2. This is second pair. The third pair is alpha plus 2 and gamma plus 2. This is the third pair. So expanding this, we'll be having alpha beta, this time this, and this time this. You'll be taking 2 outside, and this is alpha plus beta and then plus 4 in this part. It means 2 times alpha times 2 and 2 times beta, so this part giving. In the same way here also, we'll be having beta, gamma, again 2 outside, beta plus gamma, and then plus 4 again. In the same way here, alpha gamma plus 2, alpha plus gamma, but then plus 4. So when checking on this, you will be finding there is alpha beta, beta gamma, alpha gamma, which is the sum of pair, this one. So negative 4 over 3 plus. And then taking this pair here, this pair here, and this pair here. Upon summing, you'll be having 2, 2, 2. But they all have 2 alpha and 2 alpha. So 4 alpha, 2 beta, 2 beta, 4 beta. So you'll be having 4 outside, but with what? With the pair, with the sum of alpha, beta, gamma. So alpha, beta, gamma, negative 2. In this case, you can see how we say. Because 2 alpha, there exists another 2 alpha. But 2 beta with another 2 beta. So 4 beta again. With gamma, 2 gamma. And so they all contain 4. But inside becoming the sum of the roots, which is this negative 2. But there exists also 4 and another 4. So this is giving 4 times 3, 12. So with this case here, negative 8 with 12, that is positive 4. So positive 4, negative 4 over 3. Summing this to find the LCM. 3, negative 4 plus 12. So this one is giving 8 over 3. This result is the one which is coming for the part of sum of pair. This is for the part of sum of pair here. Sum of pair. So with the product, we will be multiplying alpha plus 2, beta plus 2, gamma plus 2. So multiplying, expanding this carefully, alpha, beta, and then we have 2, alpha plus beta, and then plus 4. This result is also multiplied by gamma times 2. So multiplying again, here is alpha, beta, gamma with this going, with this part going here, alpha times beta here. So this is going to become what? When we multiply on this, because this one we have multiplied, the product of the roots, alpha times beta times. So alpha times beta, alpha times 2, 2 times beta, they all take 2, 2, 2. And again, let's go. There is also this 2 which is going to come. So when you bring here, this time this, but this time this is going to give what? 2 alpha beta. It means alpha gamma, we say. Alpha gamma. And then 2 beta gamma. So because this gamma is going to multiply all. Come to this same. Again, this is giving 4 gamma. So you'll be coming with 2 again. 2 bring inside. This is also 2 alpha beta with this 2. Again, in that case, 4, that is what? 4, that is to say 4 alpha, again 4 beta, and then keep on multiplying. This is giving 8 in this case. So collecting like terms together, there exists alpha, beta, gamma, which is the product of the root. This is negative 7 over 3. Again, with coming with these 2 terms, 2 alpha, beta, 2, we have 2 alpha, beta here, but again we have 2 gamma, beta. We have again 2, so you will be having 2 sum of pair, which is negative 4 over 3. So we are done on this. We are done on this. We are done on this. Again, we are done on this. And we will be remaining with this, which is 4, 4, 4, and 4. But this taking 4 outside, that is a sum of root. So 4 outside, sum of root, which is negative 2. And we have plus 8 up to the end. So finding the LCM on this case. Finding LCM in this case, this is going to give us a result which is, so we could be substituting here. So come to write our equation, our polynomial x cubed with the result with the sum of the roots, which was giving negative 4 x squared, with the sum of the pair, sum of pair of the roots, 8 over 3 x, with the product of the roots, the end part equals to 0. This product is the one getting the result on this part, performing multiplication. This is 0. So 3 is easy to get. So we say negative 8 and 7, 15. 15 over 3, 5, yes. So that is negative 5 equals to 0. So this is a equation of the polynomial when given the roots with plus 2, beta plus 2, and gamma plus 2. Let's check with B and see how it works. Let's go. So let us check with B how we could be treating with B. Now with B here, we could be treating the same, just taking the sum of root, alpha plus beta plus gamma. This is known from there is negative 6 over 3, negative 2. But when you take alpha beta, you take beta gamma, you take alpha gamma, that is C over, so becoming negative 4 over 3. Alpha beta gamma, negative D over A. So this is negative 7 over 3. Now we are told, find the equation whose roots is 1 over alpha, 1 over beta. So with this one, it would be really simple. We simply taking like that, like this, x cubed minus the sum of root, 1 over alpha, 1 over beta, 1 over gamma, x squared, plus sum of root, 1 over alpha times 1 over beta, plus 1 over beta times 1 over gamma, plus 1 over alpha times 1 over gamma, x minus product, so alpha, beta, gamma here, then giving what? 0. So with this, it means finding LCM this, x cubed. The LCM here is the alpha, beta, gamma. So LCM here, this is giving beta, gamma. This is giving alpha, gamma. This is alpha, beta, x squared plus. With this, the LCM here, it could be alpha square, beta square, gamma square, because of this and this and this. So when upon taking this divided by this, so we'll be having alpha beta gamma square. Here is giving with this beta and gamma. So we have beta gamma alpha square plus, yeah, it's supposed to be extended a little bit. So with this one, alpha gamma beta square, this is x, so minus, but this is a product. So putting the sum for product is going to become plus 3 over 7. This is going to be a rest block. When you put the 3 coming up, so be giving 0 here. So we are now having the sum of pair of roots, which is negative over 3, and the product this. So putting there is going to become 4 over 7. So x minus 4 over 7 x squared. So plugging this and this. That is cancellation. Taking this over the 3 is going to cancel. So 4 over 7. So negative over negative. So that is why this negative outside is maintained. So we are going to treat on this. Treating on this, you must be taking the common factor outside. Alpha, beta, gamma outside. So here you're getting to have alpha plus beta plus gamma. With the denominator, you have alpha square, beta square, gamma square. But this contains x with plus 3 over 7 equals to 0. But this one, so reduces 1 here. So we'll be having the same. So putting the sum of root here, negative 2, and here the product of roots. So we have neg x square minus 4 over 7x square plus, this one is negative 2. With this one, which is cancellation of these squares with this, so we have only one product of roots. This one is 7 over 3. 7 over 3. So 3 is going to come here and 7 here, but connected with x, plus 3 over 7. So this is the equation of, this is a desired equation. Simply multiplying 7 both sides. 7x square, 4x square. This 7 has gone. So minus, we say, minus 6x plus 3 equals to 0. This is our equation. It is also a polynomial. This is a polynomial. This is power 3, sorry. Supposed to be power 3, 7x power 3. So let's check with B, with C. This is a so unique part. Let's check with C. With C, we are told we want to find a polynomial equation with these roots. So with this, we say, checking for C, we could be taking x cubed minus sum of root. One root is alpha plus beta, another root is beta plus gamma, another root is alpha plus gamma. All this takes x square. This is one of the root. And then, so you could be performing this one, is giving 2, 2, 2. So x cubed minus, bring 2 outside, becoming sum of root, which is negative 2 is known here. So x square. So with this, we want to find the product of roots. So sum of pair is alpha plus beta. This is going to be multiplied by beta times gamma. Is another pair is beta plus gamma, is multiplying with alpha and gamma, plus another pair is alpha plus beta, so is multiplied by alpha plus gamma. So the entire here, this one takes x, and minus is the product of the roots. With the product of the roots, alpha plus beta, another root beta plus gamma, another root is alpha plus gamma. This one is also giving 0. So, class, you can see this is really an interesting part. So with this which is known, we could be writing aside here. We could be writing aside here that this is x cubed plus 4x square. That is supposed to be 8, yes, plus 8x square, negative 2 times this. So you must be toiling, performing the expansion on this part. So performing the expansion on this part, this one expanding carefully, alpha times beta, alpha, so you could be alpha beta, you are getting alpha gamma, you are getting beta square, you are getting beta gamma. So it means you have to take alpha times beta, alpha times gamma, gamma. So coming here again, we have alpha beta, again multiplying this. We have beta gamma, then coming for this one, we say this is alpha, because we have taken beta times the alpha, and then beta times gamma, which is this one. This we are alpha times gamma, so alpha gamma, and then gamma and gamma, this is gamma square, plus. So coming with this, alpha square, and then we say alpha gamma, with the alpha beta, and then next, this is the beta gamma. The entire one, this contains xe. So what are we going to do? You'll be checking alpha beta. There is another alpha beta. There is another alpha beta. There is 3. Let's check again. Beta gamma. Again, beta gamma. There is another beta. So there is also 3. So we say this one is going to appear 3 alpha beta, beta gamma, alpha gamma. So all these ones, they keep on cancelling. They have all cancelled. These ones, they have all cancelled. So we only have what? We have plus alpha square, beta square, gamma square, which is this, and this. Now that is where the challenge comes. And that is where the importance of identities, where it works. It means with this one, we have the sum of pair of roots, which is negative 4 over 3, So with this, we will be saying 3 times negative 4 over 3. This is with the part of the sum of pair, which the result is known from this part. But the challenge now comes on how do we get this? This one is simply obtained just starting from this important identity. So from this important identity, wherever there is a plus b plus c is like the sum of root where the result is negative 2. So putting negative 2 becoming 4 equals 2 because this is square. So a square plus b, this is the alpha square, beta square, gamma square. This is the one we want to get, this one. So with this, the sum of pair is also known, which is negative 4 over 3 is the one which is plugged there. So 2 times, in that case, so negative 4 over 3. Now you can see how it is interesting. Now with that case now, you will be having this 8 over 3, negative 8. Bring to the other side. So becoming 4 minus 8 over 3. It's going to become positive, I mean. So over 1. This is a result of alpha square, beta square, gamma square. So working on this, LCM is 3, 12 plus 8, this is 20 over 3. Yes. So the result, alpha square plus beta square plus gamma square, this is 20 over 3. Now this result is the one which must be plugged in this part to find the result. So what are we getting now? We will be simply taking negative 12. This is cancellation, we can say. So we can simply cancel, say, negative 4 plus 20 over 3. 20 over 3. So with that one, we find LCM on this case, 3, negative 12 plus 20. So this is what? Positive 8 over 3. So if it is positive 8 over 3, we are in a good position. Where this our equation here is now written as what? Now this equation is written as x cubed 8x squared 8 over 3x. So you want to get to find the product of the roots. So with the case for the product, this is the case for the product which is here. Now that one is nothing more than expanding. So how do we expand on this case here? The case for the product. So we must be expanding. Expanding this one. Alpha times beta, alpha beta, plus. We have alpha gamma, plus. So we are coming with beta. Beta square, plus. And then we have beta gamma. This result also must be multiplied by alpha plus gamma. So expanding this, we have alpha square beta, multiplying on this, alpha square gamma, multiplying this, alpha beta square, multiplying with this, alpha beta gamma, plus, bring gamma again here, alpha beta gamma, plus, again this is we have alpha gamma square, we are in the other part, this one again, this is giving beta square gamma, plus, then we ending here with beta gamma square. You can see this one is too good. With that one, we are now in the position of concluding. Where do we say? This one and alpha beta gamma, those exist 2 alpha beta gamma. So with the result is known, negative 7 over 3. So negative 7 over 3 times 2. So we are done with this, Now what is remaining? We are remaining with alpha square, beta square. So we write like this. Whatever there exists a part with alpha, we will be writing in that trick. We say, wherever there exists a part with alpha, we check which one is supposed to be written as condensed outside. So we check. Here we have alpha square, beta, alpha square, gamma. Do we have another term with that? Let's look another term. Beta square, again, beta square. Let's go. Again, we have what? We have, so we take like this. Alpha square, it must be outside of what? Alpha square, is outside of what? Of beta plus gamma. So I'm adding alpha minus alpha. I have not changed the meaning. We are done with this and this. Again, I'm coming here. I'm taking beta square outside. I'm taking alpha plus this one, beta square and this beta square, plus gamma. So beta is missing. I'm adding plus, I'm subtracting beta. In the same way, gamma square. I'm taking alpha plus beta. So beta is missing. Gamma is missing. I'm taking plus gamma minus gamma. Using this trick is the one where you can tell someone that you could be setting these ones, setting these ones, setting these ones as a common factor. So common factor, with that one, you'll be having this negative 14 over 3. This one we have taken outside. So taken outside, we are going to get what? Alpha plus beta plus gamma. And here alpha square plus beta square plus gamma square factorization. I mean, this will take this, this will take this, this will take this. Now what is remaining is when this alpha square goes inside here, you're going to have minus alpha cube, beta cube, gamma cube. Yes. But here we are in the end part. You know why? We take this negative 14 over 3 plus. This part is a 1, sum of roots, negative 2. Put here negative 2. Alpha square, beta square. This is a trick we have from this result. We got from this, which was 20 over 3 here. So 20 over 3 here. Minus alpha cube, beta cube, and gamma cube. This is the result which we need to get it. Getting this from where? From this important identity on this. Where you have alpha plus beta times beta. You have this as a product. You have this and you have this. Treating carefree on that result. This one, treating carefree, this one is giving negative 23. You treat carefree. You know why? I'm using this formula here. This is the one we want to get. This is a product which is known. Negative 7 over. ABC, the sum of root, which is known, negative 2. Sum of A square, B square, C. This is the one we have got, 20 over 3 here, plugging this. This is a pair again. A pair is also known. Getting negative 23. So solving carefree on the result and ending also at the end, this one is giving 64. The entire part here giving 64. So our equation when coming this was supposed to be added 64, which is the result. You can see how it is interesting. And here the question is so challenging. We are taking a short break. But wherever you have any challenge, if you want to give us any question regarding with the problem you are facing with this part, do not forget to send a message through a WhatsApp, or you can follow us an Instagram page we call Elimika Darasa. Or if you go for YouTube, you'll go for subscribe Elimika with this telephone number 0769 048 594. I'm repeating 0769 048 594. So thank you very much. We will be right back. Don't go away.